Howdy, welcome back to Space Teams. This is lesson 3 on the SimConfig. The SimConfig is basically the way y'all will be running your simulations on your own. So you use a text file format called JSON. We have a ton of built-in blocks of code that you guys can use to do whatever you want with your sim. So I'll show you what we're trying to do today, which is basically putting a rover on the moon, very simple, and then I'll take you through the JSON code, which is used in VS Code, which y'all should have set up in the first lesson video. So by the end of this video, you should have an understanding of how to use a JSON to do what you want in a sim, and as these lessons go on, we'll build on the JSON and different systems you can use in it. Something you should know is in the description of this video, if you follow that link and look in the wiki, there is a page on the SimConfig that has all of the different systems and anything you can use in your JSON file, and that is in the link, so just follow that. So just wanted to show y'all what we're doing today, and we're just putting a rover on the moon. Simple as that. A rover that's already built by Space Teams, so eventually you'll learn how to put your own rover on the moon that you imported. That's a video coming up in this series, but for now we're just putting a rover on the moon, as you can see here. Okay, when you guys make your own code, you're going to want to put it in a very specific folder, in my opinion too specific, but just follow along with me and put it in there. You can make a shortcut anywhere else to get to it easier, but I'll show you in VS Code afterwards how to get to it. Just make sure you do not put the code inside of the Space Teams folder itself, because if you update Space Teams, which you will lose your code in the old Space Teams file. So do not do that. Come to your this PC, go to local disk, users, your username, and then app data, local. Scroll down to Sim Dynamics, Space Teams Pro, Assets, and this is where you put it. I know it's a very long file location, but when you're gonna recall your code in JSON, which I'll explain in a second, don't worry about it yet. It's a lot easier putting it in here, and this works the best. It will also work within Space Teams. This is the file location it knows. So so you can see I made my own folder with my name. You don't have to do that. You can. I just wanted to, and then I did some organization. Again, you don't have to do this, but I did. But if you see in here, I have all my JSON and Python files, at least in the assets folder. So Space Teams can find it, and you can find it in VS Code. So just make sure you do that. These files need to be in the assets folder at this location. I'll show you in VS Code what that looks like. Okay, last time we talked about VS Code, I left you guys with Compute Server open, and this is good because if you come in here, you can open examples. So like, here's an example Python sim. You can take blocks from this. Again, I'll explain what this is in a second, but what you want to do is make your own code. So you're not going to put it in the Compute Server like we said. That would delete when you re-download Space Teams. So you're going to go to File, you're going to open Folder, and then you are going to go to this PC, local disk, run through the same thing we just did to the folder that you guys have set up now. So local disk, then users, your name, app data, local, and then Sim Dynamics, Space Teams Pro, assets, select folder. Okay, so now we have assets open. The way I had it organized was my name, code, and here are my example sims. So let's open the one we're going to use for this video, rover2 JSON. This is what we saw earlier in the video. This JSON set up the sim that we watched in Space Teams that put a rover on the moon. So yeah, so basically the way that Space Teams works is it's going to read these JSON files you make. I'll go through the whole thing and tell you what everything does. And then any system that you want to add, so let's say you want your rover to move, that's Python. So then that Python system can be used within the JSON. And that will make more sense as we go on. But yeah, so this right here is exactly what you saw earlier in the video. Just it's how we did it. One thing to note, this will be linked, so go to the link in the description, it will take you to the wiki for the video, and this will be linked so you can take code out of it and use it for your own sim, whatever you're trying to do. One thing I'd recommend doing too is go to File and put autosave as on. You don't have to, but I would. I save every time anyway, so you're gonna be doing stuff in here, going back to Space Team, seeing if it works or not. But you should have autosave, so it makes it easier. Okay, so let's get into the actual JSON file. This top part right here, meta include this right here that is highlighted. You just need that. That basically starts a sim. Description, I just put bruh. You could put whatever you want. I don't know why I did that. But yeah, title too, you can name it whatever you want. Include sims. So this includes a base JSON that has already been built by Space Teams. So this is one of them. This is a solar system sim with moon at the center. So this, if I just did that and ran it, it would be a solar system, like just solar system with the moon, with all the planets. It would just set your reference frame as the moon, but you need one that you start with. This is built by Space Teams, so yeah. Let me close all this so that you guys, I'll go through all of it with you. Yeah, so you could see there are like few main sections. So this side arrows, by the way, open and close things. So meta is what we just looked at. Just make sure you have that in there. Included sims, we just looked at that too. So those sections are good. Then there's two more, system manager and data manager. And the way to think about these is your system manager is systems you have included, and those can be either systems that have been built by the Space Teams team at A&M, Sim Dynamics, or built by you. And the ones built by you are going to be Python. So those are Python files you will have in that file location that I said. This JSON, by the way, is also in there. Make sure of that. But yeah, so if let's say the rover I showed you on the moon, let's say I want to make that move forward for 10 seconds. I would write a Python code to do that, and then I would put it in the system manager. That is future video actually, so you will get there. Don't worry about it yet. But yeah, so you can see these different systems. We'll go through all of them and what they are. The data manager. This is where you have your entities. So an entity is a model or a rover or a planet or anything like that. So in this example, a rover. Also your spectator, so your pawn is an entity. So basically the way that this is set up is you put systems in here, you put your entities in here, and then you apply these systems to these entities. And you'll see that as we go through it. So let's start with the system manager. Make sure you follow, just when you're making your own JSON, just do the same copy, like literally copy and paste from the wiki or from this, so that you have the same syntax. Syntax is really important with these brackets and commas. Just follow it. It's pretty self-intuitive, but if you try to write it yourself without knowing the syntax, it might be a little harder. But yeah, so you're gonna have systems, system manager, systems. First one is data monitor. This basically is used to create data of your entities. So if I have a rover, like in this example, another window can see like the velocity or the location or the any parameter that model has. Data monitor is used to get that data. So just include it. It's helpful. The next one, Param Wrangler, is the actual window that does that. So you don't need Param Wrangler, or you can take that out right now. But what it does, you'll see in you've seen in the sim, and you'll see at the end when we go through it again. It is a pop-up window that uses the data from Data Monitor to so I can look at my velocity as a spectator, or I can look at the rover's velocity or its position or a ton of different things. So we included this because it's helpful for any sim you're doing, because you're going to want to know things about your objects. You don't want to just see it. So Param Wrangler is very helpful. Spicy is just a library that JPL has made and NASA has made, and it's real-time data on planets and the solar system, and is used just to run the sim accurately. So definitely include this. Also make sure in all of these you see active, put them as true. If it's false, then your system won't run, which is fine if you don't want it to. So for example here, I could set Param Wrangler to false, and then I won't get a window pop-up, which if I don't want a window pop-up, that's great. That means I don't have to delete that whole part of my JSONs. I might want it later, but we're using it, so we're going to have it as true. Snap asset to planet. This is what puts the rover on the planet. So whatever location I set to the rover, which you'll see later, this puts it on the planet. See active true again. These type, frequency, parameters, these are just needed for the snap asset to planet system. So this is not stuff you're actually writing here. This is stuff that you will copy. So if you want a snap asset to planet to work for the moon, you copy this code and you put it in your system manager. You can see here, and you reference moon. If it's a Mars one, that will say Mars, and these data sets here will, for Mars there's a lot more data sets, but these data sets here will be Mars data sets, and these doubles will be assigned to those data sets. So as you can see, we have two doubles assigned here. These just work together. So the Mars one is a lot longer, a lot more doubles, a lot more data sets. But for you, it's just copying it in. It's just a system already working. Here this is not used in this video. This actually is false. But this is a system that you will see in a future video. This is a Python system that I wrote to move the rover in a certain to move it in a triangle basically, but it's just an example. But this is just showing you that you can run your own system, so you can put your own systems in here just like any other system, except you wrote it. And there'll be future videos on that, so don't worry. Last thing here is task flows. That is a way to tell Space Teams the order that you want your systems to run in, which we don't need that for this example, but for the next example, for the satellite in orbit, you do, and we'll talk about that in that video. Okay, so we are done with System Manager. You should know what that is now. We're moving on to Data Manager, and this is where you have your entities or your objects, as same word. So you have Data Manager. Sim Entity, this is just needed for the simulation. This just, again, just like Meta, this sets things up, like the year, the month, the day, graphics frame. This is important. You want it to be referenced to the moon in this case, or Mars if you're on Mars, or Earth if you're near Earth. But this is just setting it up so that you can do entities here. So just copy this in. set your graphics frame to whatever body you want it to be. In this example, we want it to be moon, and then move on to entities. So the first one is spectator 1, which means you can spectate your sim, which is very important. Type pawn systems. This is where you apply your system, any system that you wrote in the system manager, to an entity. So for spectator 1, we have param wrangler, which again is the one that puts a pop-up window that tells you parameters on your entity. So I could see, if I start moving in the sim, I could see how fast I'm moving. I could see my acceleration. I could see my change in position. A ton of other things too. So this is cool to have in here. This is not necessary again, but any system you want to apply to an entity, you have to put it in this systems box in here. Same syntax, so just follow it, the quotations. If you wanted to, it would be a comma, and then your next system you'd write in there. We don't need any for spectator 1. We do have more on the rover, as we'll see. This is again just stuff that you need in here. Blueprint path for your spectator is going to always be this. For other entities, it is different, and I'll get to that when I explain the rover in just a second. Is possessed, make sure that's false. Username, that doesn't matter. Gadgets, these, you don't need them in here for this sim necessarily, but what they do is when you go into Space Teams, you see the top of the screen, there's multiple things that you can pop up. So like time, camera, planet graphics, outliner, which we covered in the other videos. Like this is how you look. You could select different entities. So yeah, so the gadgets go in under your spectator. You can add other gadgets if you want. Those are on the wiki. Different ones that you can use, but you could delete these. Leave them here because we want to use them for the sim. Yeah, there's a lot of different ones in here. I'm not going to go through and explain all of them because if there's any you want to use, you can look at them on the wiki, and they're not important towards what we're doing in this video. But yeah, they're helpful if you want to do anything on the top of your screen like that. I mean, in Space Teams. Dynamics, again, this is all under spectator. Dynamics, you just leave all this. Make sure is rebase center is set to false. Rebase center is basically changing the center of your sim to whatever entity this is applied to, if that was untrue, and that messes with the math and physics behind what you're doing and sometimes crashes the sim. So set that to false for now. Generate collider, set false. Mass is not important for what we're doing, but if you wanted to do any physics with your entity, it's very important. So if you wanted your entity to be in orbit or to anything like that, you need to change mass. This is where you would, but again, this is spectator, so it's not going to be very important. Resident frame, make sure that's set to moon. Graphics, scale, see, this stuff is just leave it for your spectator. This is going to become a lot more important for other entities. Render far, true. And then here is location. This is important. You want your location of your spectator to be the same as the location of your entity so that you can see it when you load into the sim, at least in this very basic sim. So we set location to this, which is taken from right here, the Shackleton rim, Shackleton crater rim on the moon. All these here that I am highlighting are just examples. These don't actually change the sim at all. These are for you to use if you want to load in certain spots on the moon. Otherwise, you're going to have to find other spots, and it's harder to do that. So you can copy any of these locations and then paste them into your actual location, which is the top one location. Rotation, that changes how you're rotated, how you start in the sim. Again, these are instant parameters. So if you run a Python system on an entity, you can change these parameters. So your your Python system will take will be the one that matters more. So if you have a Python system telling an entity to move, it's not going to just keep going back to this location that you set at the start. This will just be where it starts, and then your Python system will take over. So these are instant parameters. You can't change anything here as the sim goes on. But set your initial rotation, velocity, angular acceleration, angular velocity, angular acceleration here. Those are all 0, so you're just still. Transition graphic frame, transition resonant frame, set those to false. Constrain z-axis to planet. That's set to true because it orients you with the planet so that you're looking as if you're staying on the planet. That's just helpful. I would set that to true. Movement speed, again, initial speed, you can change that with a Python system, but we're not doing that, so that's going to be 0. No clip, just set that to false. Height, I set my height to 10. This is, again, is an initial parameter, so I don't want to spawn on the planet. I spawned 10, I believe it's meters, I believe it's in meters above the planet. Yeah, so that's a lot for the spectator entity. Yeah, but now we move on to the rover entity. So as you can see, named rover, type from template, leave that in there. Systems, I have a lot more systems on the rover because I'm doing something to the rover. I have param wrangler, I have snap asset to planet, and in this case I have rover 1 system. This again is my Python system that I wrote. I just wanted to show you guys that you can do this. For this specific example, we're not moving the rover, so delete that. We have it set to false in the system manager anyway, but delete it. But that shows that's where you would put a Python system on an entity. It would be in this line. You would put it in the system manager as we showed, and then you would reference it here so that that entity is using that system. But we have param wrangler, so we can see the velocity, location, all that stuff in a separate window. And we have snap asset to planet so that the rover is snapped to the planet. So here is your source path. Do not copy this one. This is not the right source path for the rover used in this video. This, if you go to the description below, click on the link and find the JSON, which is this exact JSON. This is actually different. This is the source path that we are using for this video. Do not copy this one again, copy that one. But everything else is the same in JSON. If you wanted to do your own import of your own model, this is where you would do it, and there will be a separate video on that. But source path basically tells the system what model to import. And a model import is a little bit different. You're going to change some of this code here to do that. But this is taking a model that is built into Space Teams, and that's why it's a lot simpler here. Param overrides are just different. It's similar to what you had up here. These are just parameters that are set initially. Propagation type, set that to compute velocity. This is important for snap asset to planet especially. Different systems use propagation to do their calculations. So you need your propagation set to something. If you have no propagation, then snap asset to planet won't have any data to run on to snap your entity to the planet. So in this case, you have computed velocity. That one works. There are other ones to use, and those are also in the wiki, so go check there and you can find some more. Interpolation type, set that to no interpolation. We don't need that for this example. Resident frame, entity reference moon. When I say we don't need it, I don't mean don't take the line out. I mean leave the line in, but just copy it the way it is. Resident frame, make sure you're referenced to the moon again. That makes all the math work out in your systems. Is rebase center, again, false. Make sure that it's false. You'll have glitches if you don't. In the future, there are things you might want to do that use that, but for now, false, for sure. Generate collider, true. That's not too important there for what we're doing right now. Later on that will be, don't worry about it. Mass I set to 0. That doesn't really make sense, but I'm not doing any real physics-based stuff by just putting it on the moon right now, so that doesn't matter for this video. But if you wanted to set a mass to your entity, this is where you would do it. I believe it's in kilograms, if I'm not mistaken. Inertia body frame, just all this stuff here, copy into it. Again, this is stuff that is used for more complex initial parameters that you might use later on, so there will be other videos that use this kind of stuff, but for now just copy the numbers and what they have in here to just set it to be basic. Graphics, scale, set that to 1 for this example. That's what's going to work. Other models might need different scale so that it's the right size. Render far, true. Is light source false? Your light source is the sun. Set that to false. Your rover is not lighting up the moon. So yeah, this does not actually need to be in here at all. In a Python system, test double was a number that changed based off of parameters in your on the rover. We're not using a Python system. This actually, I would go ahead and delete this. It doesn't make a difference because there is no such thing as test double because you're not running a Python system that uses it. But yeah, with that's kind of an example of how you would use a parameter to change some sort of, the number could be oxygen or it could be battery life on your rover. Like, it could be battery life on your rover, and that number is going to change. And when it says test double 0 there, that's setting your initial number to 0. So that could have said, you know, battery life 100, and then your Python could have taken that test double and changed it as time went on, and your battery life would have gone down. That's just was an example of showing that that's where you would do that, but that is a little more complex. So that will be more videos. Don't worry about that exactly for now. But again, that is important. If you wanted something like that, you would need to set an initial value to to whatever number you want. Yeah. Okay. Location, rotation, velocity, acceleration, all this stuff. Again, location. I set the same location as my spectator location, so we spawn in the same spot. Rotation, this I messed with to set the rover in the right rotation. That might be different for your sim. This uses a quaternion, which is a little more complex way of explaining rotation, but when you set it in here, it's going to use the regular system of rotation, so rotating about the z-axis or x-axis or y-axis. So yeah, so this will just set a rotation, velocity, initial rotation, initial velocity, all this initial again. But yeah, that is your JSON file. So basically using these 4 subsets of your JSON, you can run a sim. Make sure a lot of this is the same, and just change the things that you want to change for your particular sim. And you can add systems, add entities, and that's how you do it. So I just want to reiterate what the JSON does before we go into the actual SimConfig in Space Teams. So like we said, there's 4 sections: Meta, Included Sims, System Manager, and Data Manager. These are all very important for running your sim. Meta sets up your sim. Included Sims is the base sim that your sim will be running off of. So if you're on the moon, you'll be running a solar system, moon-centered sim, and then doing whatever you want on the moon. There are multiple of those, and they're in the wiki, so you can look through them. System Manager sets think of each system as a variable that you can use in the data manager. So you put a system in the system manager, and if you set it to true, like active true, you can use it. So your own Python system, any other system that is already in Space Teams, and there's plenty, as you can see, like Param Wrangler or Snap Ask to Planet are built into Space Teams. And then in Data Manager is where you set up your entities. So in this example, we have the spectator and we have the rover, and you set those systems to those entities and then they run them. So if you have a Python system, you could put it towards an entity. If you have Snap Ask to Planet, so you want your entity to be on the planet, you use that system in the entity in Data Manager. Yeah, so that's how it runs. If you do all that correctly and you run your sim, it should put those entities in the sim and run those systems on those entities. So yeah, now we'll get into the actual sim itself and show you again it working. Okay, so you're going to open Space Teams and you'll see this screen after you log in, as we talked about in the other videos. You'll come over to Sim, and it will probably be on core made sims, checked as that, so change it to user made sims, and you can see all of the sims that you have made, and that's going to be based off of that folder that I told you to put all your code and JSON into. So make sure that it's in that folder, and this should work. You can also search up here for it, and so we're going to run our rover system that we just worked on. Press confirm. Okay, once you're in, pick spectator, because that's the pawn that we made. Start simulation and let it load. Okay, so we're in the sim. You should see a rover on the moon. Hopefully that's what you do see. I think it's pretty cool. So this is a built-in rover that Space Teams has, and as you can see, it's in the spot that we put it in on the moon. You can use Param Wrangler to see that. Here's Param Wrangler open now. So you can see Spectator 1. Go into Dynamics, and you could see the location of, or Param. So Dynamics or Param, you can see the location of Spectator. So here's our location. I think this is different. It's a sim-based frame, so this is more for the computing side of things. I would look at the params part of Param Wrangler, and you can see our location as far as XYZ on the moon goes. And if you look at rover 1 params, same location, and you can see that our rover is here, obviously. Yeah, so just remember, like, if you load into the sim, you might have been loaded like this, like really close, so you just have to back up. Remember that the wheel on your mouse is to speed up or slow down. See, slow, fast, WASD, like normal. Also change the slider, so to change the exposure, you might load like this and not see anything. Just try changing it to there. You might like load in like this. Just put it to where it looks good. And then one more thing to help you find the entity is if you go up to the outliner up here, which was in our JSON code. We programmed that in when we were doing the spectator, actually. You could see like all those boxes that were like outliner, chat box, sampling display that we programmed into the sim. If you look in outliner, you can press on any of these really, but if you press on rover 1 and press go to, you'll go to the rover. You could see that tiny green box there, and that's signifying the rover. So if I'm not on the rover, that green box won't be there. If I am, I don't know why it's really small right now, but if you back up, you can see like it tells you where the rover is, right? So like if I'm all the way out here, okay, where is my rover? Well, yeah, so if you're all the way out here, I have no idea where the rover is, right? I don't know. Press rover 1, you'll see the green box. You can fly to it, or you can just press go to, and boom, you're next to the rover. So that's how you find your entities really easily. Yeah, that is it for showing you what we just did today. Okay, one more thing I want to mention really quick is if there's any problem running your sim, like an error message or something not working in your JSON or Python, what you're going to want to do is come into Space Teams Pro, the folder, to Compute Server, Logs, and then look at these text documents. Space Teams made these to tell you what is wrong with the sim you just ran. So if I just ran my sim on Rover 2, this will tell me what's wrong with the JSON. It's not going to do it here because I didn't actually run the sim, but at the end, if there's an error, it will tell you, like, on line 72, there's this error, I couldn't read this correctly, so then you can fix it. Some of these will also be Python, so here's the Python system. See Py system? If you run in a Python system and there's a problem, at the bottom it will tell you what the problem with that system is. So yeah, so if there's a Python problem, look at the log file for the Python. If there's a JSON problem, look at the JSON file, and you should be able to see what's wrong and then go back in your code and fix it. Okay, thanks for watching the video. You should now know how to create your own SimConfig, and as these videos go on, you'll learn more and more about the SimConfig and what you can add and what you can do to your sim. And we'll go over Python too, and how to make your own Python system that you can then apply to those entities. So there's a lot more you can do, but this is the most basic one, and hopefully you have an understanding of it now. Yeah, thanks for watching. If there's anything that you didn't get from this video that you need, go to the description and then it will take you to the wiki for this video. There is the JSON file that we used. There's other information and other things that you can use in there to make your own system, whatever it is you want to do. So, thank you.